Hi guys, today we are going to talk about naming compounds and how to name compounds chemically. Okay, so several things that I want you to know is the term binary. Binary means two or more elements combined. Okay, they're always composed of at least two elements. If you go into three elements, you're into the polyatomic ions, so keep that in mind. Binary compounds, which are made of two elements, are ionic and covalent compounds. Okay, and we'll get into that. Ionic means you have metals and nonmetals. Okay, those metals bond with the nonmetals mainly because metals are a positive charge and nonmetals are a negative charge. Okay, so they try to equal each other out. Those are ionic compounds. Those are also what make up your ionic bonds, or are composed of ionic bonds. Binary covalent is your nonmetals bonded with your nonmetals, also called a covalent bond. Okay. If you look on your periodic table, because I'm sure all of you have periodic tables at home, right? You notice here that all of your nonmetals are through here to the left side of your periodic table, and your nonmetals are right here in this upper right-hand corner of your periodic table, except for hydrogen, which is on the metal side. Okay, so keep in mind that hydrogen is still a nonmetal. Okay? So the first type of compound that we're going to name or have you name is binary. Type 1. Okay, you've got your ionic compound, which is your metal bonded to your nonmetal. And you always put the cation first. That one kind of gets the parent name. Okay, so it's always going to be its actual name. And then the second ion, or anion, meaning the negatively charged atom, so usually your nonmetals, comes second. And when we have these monoatomic cations, they take the actual name of the parent, but the anion, the nonmetal, always ends in "ide." Okay, so I'm going to go over a few examples of that here in the next slide. So for example, just a few examples, you have a metal, potassium, with your chlorine atom, which is a nonmetal. Alright, so you got a positive charge with a negative charge. And at that point, you notice the first one takes the parent name, so it's just potassium. And notice on the second word is not chlorine, we've added an "ide" to it, so it's potassium chloride. Okay? Another example would be MgBr2, which is magnesium bromide. Now notice here, it doesn't matter in your type 1s, right, with these ionic bondings, that there's two or more elements here, okay? If there's more than one molecule, it's okay. That's not how type 1s work, but we will get into that later when we get into type 2 and type 3. Then your third example is CaO. So notice that calcium keeps its name, and then oxygen turns to oxide. Okay? So those are your metal, nonmetals, or your binary ionic compounds, type 1. Okay? And one thing I want to point out is, you know, when we come to quizzes or tests, depending on your level, if you're a beginner level, I'll say, hey, name this type 1 binary ionic compound, you know, CaO, and you'll say calcium oxide. If you are AP Chemistry, I will give you a list of elements, and you got to figure out what type it is. That's more advanced level, right? You already know what you're given. Now it's up to you to figure out what you have, metal versus nonmetal, and figure out what type it is. Okay? So keep that in mind when you're preparing for tests or lab. Binary ionic type 2 are all of your transition metals, meaning on your periodic table it is all the metals that are in transition, meaning the center section, groups 3 through 13. Okay? Right here, well, that excludes 13 actually, so it's just 3 through 12. Okay? Are your transition elements. There's some at the bottom there, but keep that in mind that you've got your metalloids going diagonal on the right-hand side. So for your transition metals, right, your transition metals are still a positive charge because they're trying to balance out those nonmetal charges from the nonmetal elements. So in this case, we're gonna have to use Roman numerals. Okay, so at this point you can even underline transition metal cations, usually require Roman numerals. And that's one to even highlight, underline in your notes, because if you have a transition metal in your compound and you're trying to name it, you need to understand that you're using Roman numerals. And elements that form only one cation do not need to be identified by a Roman numeral. Okay, so if it only forms one, and it's a 1-to-1 ratio, you don't always need to put Roman numerals, but you can just to be safe. So here's some examples. Okay, so I've got copper bromide. Okay, so CuBr, copper and bromide. And at this point, you can get on here, on your periodic table. You notice that your bromine is going to have a -1 charge. Okay? Since your bromine has a -1 charge, your copper needs to balance that out. Right? So your copper is going to have a +1 charge. Since it needs 1 copper to balance out your bromine, you're going to end up with copper 1 bromide. Notice I'm still ending in "ide," right? It's still ionic. You still have to end in "ide." FeS, iron, and sulfur. So at this point, you start with sulfur. You look at sulfur. It's going to have a -2 charge. If you look, also look on that sheet I gave you in class. The sheet that I gave you in class looks like this. Notice it has all the charges up top, right up here, so please refer to this chart when you're doing your homework or preparing for a test. So notice sulfur has a -2 charge, so my iron needs to be a +2 charge to cancel out that sulfur. Alright, so I need a +2 charge. Since I need a +2 charge, I have iron 2 sulfide. Okay, meaning I'm going to need 2 irons to balance out that sulfur. Okay, and then you got PbO2. Now notice this O2 is going to count. Okay, so I start with my oxygen. My oxygen is a -2. Okay, -2 charge. And since there's 2 oxygens, right, 2 times -2, okay, is going to give you a -4 charge. So now I have a -4 charge on an oxygen, okay, and that lead has to cancel out. So if I have a -4 charge, I know I'm going to have a +4 charge, or 4 lead atoms, right, or 4 lead ions in this case, to cancel out that oxygen. So thus you get lead-4 oxide. Notice I'm still adding the "ide" at the end. Okay? Moving on. Now your polyatomic ions, you need to really just memorize these. Unfortunately, there's a lot of them on the back of your periodic table. Sorry, I'm holding it upside down. On the back of your periodic table, I have provided you with all of the polyatomic ions. So please, try to memorize these as best you can, but I have given you these on the sheet, especially for beginner level chemistry classes, right? It's really hard to memorize all of these, and I understand. We'll work on it. For example, you've just got NaOH, which is your sodium hydroxide, MgNO3 to the second, which is magnesium nitrate, NH4,2SO4, okay? That's ammonium sulfate, and those are all on the back of your periodic table. I have listed all of them, okay? Or you can refer to your textbook. They're also in there as well. Okay, now we're on to covalent, binary covalent compounds type 3. And at this point, it's formed between 2 nonmetals. So this is where you come to the very right side of your periodic table. These 2 elements, any 2 combination could combine in this section. And in this case, you're using prefixes. So you have to know your prefixes. So the first element in the formula is named first. And you use that first element name. You've been doing it the whole time. We're just going to keep doing it. It's how it goes. It always keeps the parent name, the very first cation. The second element is named as if it were an anion. So it's not an anion, but it's going to be named as if it were an anion. Okay? And prefixes are used to denote the numbers of atoms present. Notice prefixes. So, if you've got 2 oxygen, you're going to be using di. If you're using 1 oxygen, it's mono. Okay? And the prefix mono is never used for naming the first element, right? We don't have monohydrogen. Okay? That just doesn't make sense. You can just start with hydrogen and understand that 1 is inferred there. Okay? These are your prefixes: mono 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. Please refer to these in your textbooks when working on your worksheet or studying for tests. Some examples of these covalent compounds type 3. You've got CO2. So notice you start with your first element, which is just carbon. And then you notice you have 2 oxygen. So it's dioxide. Notice I'm still ending with "ide." So carbon dioxide. You should know this from 7th grade. Okay? That's a very easy one. We refer back to this when we talk about photosynthesis. SF6, you got your sulfur and your fluorine. Okay, so you keep sulfur, and then you notice you've got 6, so you're using hexafluoride. Notice I'm still ending in "ide." N2O4, you've got dinitrogen tetraoxide. That's your prefixes. You need to just memorize your prefixes. Okay? Notice, we don't say mono anything. Just start out with your basic element name. It always refers to there is at least 1. Okay, so here's a flow chart I've come up with. When you're trying to name, if you're in AP chemistry, if you're trying to name these compounds, if it's a binary compound, meaning 2 elements, you're going to keep going. Is metal present? If it is, you keep going. Does the metal have more than 1 cation? If not, you have a type 1. If it does have more than 1 cation, you're a type 2. Okay? Then if there is no metal present at all, and it's nonmetal, nonmetal, you're using type 3, which is your prefixes. So please keep this flow chart in mind, especially if you're AP chemistry. Now, like I said, lower level chemistry classes, I will give you that information or a hint in the title or in the question.